Go. All right. If I miss one of your questions today, I apologize. The questions are down in the bottom corner of my screen right now, so it's a little difficult, but I should notice them. So I will check the questions periodically. So if you guys do ask something, I will get to it. Usually I like to answer the questions right as they come up, but today's going to be a little bit different. I only got one monitor to work with today. So today we're looking at the 4-axis standard from inside of BobCAD-CAM. Now, before you get into 4-axis standard, the best thing you could do is understand 2-axis and 3-axis, because really all the 4-axis toolpaths that you create are pretty much just a version of a 2-axis or 3-axis. Now, that's not always true, because there's things like the 4-axis rotary toolpath. But most of the time when I work with guys doing 4-axis, there's two main things we're doing. It's indexing and wrapping. So we're going to look at an example of each one today and just kind of work through them. But again, especially with both of them, you're essentially just telling BobCAD the position to go to, or in wrapping's case, the diameter of the stock. But you're basically just creating 2D or 3D toolpaths when you do it. Normally, when you make a part, you're always going to go to the same place to create a toolpath, which is the machine setup tab. But with this one, after you create either an index or you create that wrapping group, that takes the place of the index that you might be using. Now, you don't need an index on a top plane. So like this surface that I have right here technically doesn't need anything done to it, but I do like to have indexes on everything, so that when I call out in the code, when I machine this side, I want it to say A0 right there. And I want this to be a A72 and then add up from there. So first things first, let's go ahead and we're going to pick our geometry. So what was this question? 1 second. I have to make it bigger. How do I make it? There we go. Let me see 1 second, guys. This is what I got to deal with. Come on now. Fit to screen. Okay, so Mark says, what's the difference of what does the 4-axis standard do versus the 4-axis Pro? So 4-axis Pro adds a whole lot of other toolpaths to the system. They're surface-based toolpaths. They are part of the mill multi-axis section, and they allow you to go in and use things like a morph between two curves, or just a bunch of other functions that we have. So I'll go with this. So the standard is primarily going to be an index, a wrap, or a rotary. That's what 4-axis standard has on it. You also have, that's it. 4-axis Pro is a completely different set of toolpaths that we're not going to look at today. Most people who are doing 4-axis probably don't need Pro, but for the select few of you guys that you're getting into some intricate geometry, it is absolutely worth it to have. But I'm just going to get started the normal way, and we'll kind of go through and look at the standard toolpaths here. So we're going to start by right-clicking on CAM defaults, and I'm just going to go down to New Job. From here, I'm going to choose my milling machine, and I need to pick a 4-axis machine. Now, if you have an actual 4-axis, if you've requested a post, you'll usually get a post processor and a machine together. The post department usually puts the two of them together for you. But for me, I'm just going to use this generic BC 4X mill. It has the models for the simulation, which, because I have the Machine Simulation Pro, is a little bit beneficial. 4-axis is about the time where I'd say that it is nice to have a proper machine inside your simulation, because now you're not just working with a XYZ, spindle and table. You now have your table, you have your rotary, and you have your spindle, and there's a lot more things you could start running into. So this is where at this point I would recommend, if you're getting into 4-axis, getting the Machine Simulation Pro. and working with the tech support team or the posting department to get yourself a post and a machine at the same time. Now, as far as putting models into the machine, tech support or posting could usually help you with that. There is some videos online for it as well about building your own custom machines. But you know, it's up to you if you guys even want simulation for that stuff. I've had many of you guys that I offer to do those things, and they're like, I don't need it. I can see what's going to happen. So, you know, read through your code, do your normal stuff. But we're going to go right into the stock wizard here. Now, I don't usually pick workpiece, even if I have a solid model. And really the only reason why is because I don't need it. The workpiece is any solid model that's on in your CAD window when you launch your simulation. So when I launch the simulation, I'm able to, if I don't want to see a workpiece, I turn all the layers with solid models off. If I do want to see a workpiece, I just turn on the layer that has the model on it that I want to see. So I'm not going to set up a workpiece right now. I'm just going to ignore that and hit next. And then right here, I'm going to go to cylindrical stock. I'm going to use a bounding cylinder. All right. Now the bounding cylinder, especially in this case, is helpful because I have a odd shaped part where I have this kind of boss sticking off the side. So I want to go in and say I want to do my extrusion in the x-axis. And then I'm going to use, again, bounding cylinder and tell it to calculate the stock. Now, that's not always perfect. And the reason it's not perfect is one thing I want this stock here to be centered right on XYZ0. And I'm not going to have a piece of stock that's 5.0917. It's just not something I'm going to create. So what I'm going to do is I'm going to center Y at 0, and I'm going to center Z at 0. And you'll see we get a little bit more of this kind of boss sticking out of here. But all I'm going to do now is say that the stock thickness is 5.25. And that's big enough to cover that whole thing and actually give me a cut that I can make. So after I have that set up, I'm just going to hit next. Now, I like to set my origin in the center of the rotation. I'll find X and Y right here. I'll find Z, and then I'm going to drop down whatever the radius of that stock is. That's how I always like to find my origin for this. So I don't actually have anything to change because of how I situated my part right on XYZ0. There's nothing that I even need to modify. Now, the other thing that we have to look at is right down here for the work offset. And this is especially if you have the Machine Simulation Pro, because if I could see the machine, we have on those machines a specific defined XYZ origin for the machine. So this virtual machine that's in the simulation has its own settings. And if I was to leave this origin right here like it is and go into the simulation, my whole part is going to end up inside the rotary of my machine. So what I need to do is I need to pull the part out of the rotary. And I'm going to do that by using a work offset for X. And it's going to be a negative value because right now this is the front face of the rotary and it's sitting in the part into the rotary 5 inches. So if I went to go machine this, I'd be machining through my rotary the entire time. But if I come in here and said -5, I'm now going to pull it out of the rotary. But you also want to take into account the extra stock that you might have. And I didn't add any of it onto this part, but you might want to add in that extra stock as well as give it a larger length. Right now, we're not accounting for the jaws that are holding this part on the rotary. It's just pulling it out of the rotary. So the now back face would be sitting flush to the face of the rotary. So I'm just going to pull it out an extra couple inches and go -8. And then right here, we have our clearance plane. It's going to default to 1 inch. I'm just going to go ahead and hit OK. So now that we have our stock created, I'm going to go ahead and blank that out. Now, to tell BobCAD that the first surface we're going to work on is this flat surface here, again, I don't technically need any index for this one, but I always like to put the index on the first one. One, it should be reading at, X0 or A0 for the rotation. But if my part was off even a little bit, couple degrees, and I don't notice it, then it does need to be called out because some of the rotations might not happen correctly, and I want to make sure that it does. So I'm just going to go in and right-click on Machine Setup 1. Now, inside of Machine Setup 1, you have all of your toolpaths. Now, this is normally for a 3-axis or a 2-axis toolpath. This is where we would go to add those toolpaths. I mean, this is for any toolpath. Now, what Mark was asking about earlier about what's the real difference between the 4-axis standard and the 4-axis Pro. Well, the 4-axis standard is going to give us this 4-axis rotary, and that's it for the standard toolpath. For an actual full 4-axis toolpath, that's it. The other ways that we use this standard is, again, we're going to use indexes and wrapping groups. But the 4-axis Pro gives you access to these surface-based toolpaths. There's a lot of toolpaths inside this multi-axis, but this is the only ones you'd be able to use. And we're going to do a 4-axis Pro 1 at some point. It's going to be a Tier 2 event. Just to start adding those back in for you guys that have the Advantage plan. We will be going through that. And we did do a few of them in the past with 4-axis Pro. But looking at something like morph between two curves, what this allows me to do is use the edges of a surface and make a toolpath that morphs along that surface. It's a very powerful toolpath. It's a very good toolpath. But basically what the 4-axis Pro is going to allow us to do is limit this toolpath to output in 4-axis only. So you can use it to actually create, 4-axis parts. Now, if you have just the 4-axis Pro on your license, then the 5-axis won't show up, just so you know. It would stop at 4-axis, and that would be your normal default. But we're not going to get in any of those toolpaths today. We're going to look at the indexing first. So we're going to right-click on Machine Setup 1. And again, you're not going to add your toolpaths here. You're going to add your toolpaths by adding an index first. Now, when we say add index, the first thing BobCAD's going to tell us to do is pick either a surface that represents the plane we want to machine at, or a UCS that represents the direction of the plane. And really, that's all this is doing anyway. The UCS, whether you use a UCS or you use a surface, we're basically just finding the orientation of the part and knowing what angle it needs to be at. So I'm going to just pick this top surface here. And what we always want to see when we pick our index is we want to see that arrow pointing up away from the part. If I reverse the direction and I hit the letter T on my keyboard to turn the part transparent, you'll see that one's sitting inside the part. And that's what we don't want to happen, because that means that the tool is going to try and come from this side, the bottom side, and machine that floor there. So you always want your arrow to be perpendicular to your part and usually facing the outside. You're usually going to have that arrow pointing away from the center of rotation. And because again, if you get that wrong, your tool is going to think it's coming from the opposite side of the geometry, and it gives you just a real hard time. So I'm just going to hit OK. And then I'm going to go and there's my first index. Now, it's up to you how you do your indexing. The way I usually prefer to do it is I like to go in and set up all of my indexes and name them. But giving them a name could be a little difficult. So I'm going to go ahead and do this one. I'll just right-click on it and say rename. And this is going to be my top index. All right. And then I'm going to add my next index to this side with all these holes on it. So I'm just going to go here, additional functions, add index. And it doesn't matter if the geometry has a bunch of holes in it or weird breaks or anything. But what I could do is pick that. And basically, when you pick the surface, we always just try and find the center of the surface. I've done a bunch of parts recently that have kind of a U-shaped piece of geometry. It's all flat, just a planar surface, but the entire bottom of it's missing. But when you pick the surface, because it wraps around on the left, the top, and the right, it will find the exact center of the surface. Not that it's that important. Again, all we're really using this for is to define the angle that's going to call out when we have our G code or when we have our toolpaths applied to that. So I'll hit OK. So now what I want to do is, I just got to look it up. I believe it's 72, but if I take 360 and I divide it by 5, should be 72. So the first angle, that's going to be our top index, or let me rename this top, or I'm going to say 0 degree index. And then this one I'll rename to, this should be a 72 degree index. And then the next one is going to be 72 plus 2. So times 2 equals that. So the next one's going to be a 144 degree index. And it's however you want to name it. I don't usually use the degrees, but I've run into quite a few guys lately who do use the degrees. So I'm just going to go in and add my next index. So additional functions, add index. This time it's going to be another one of these flats. Again, make sure the arrow is pointing out. I'm going to rename this. And this is going to be my 144 degree index. From there, I'm just going to continue on with the indexes. I don't usually stop making indexes until they're all done. And then that way I can add the toolpath as needed, because the first thing I'm going to do is face off the part and make these flats. So it's easiest to just make all the flats. When I'm making one toolpath, I'll just be able to copy and paste it. So it works out real nice. So we'll insert our, whoops, didn't mean to do another setup. Let me delete that. Delete that setup. Yes, I meant to do another index. So right there, we'll add our index. This time we're going to pick this top surface, just like that. You don't need to pick the inside of the floor. You could if you wanted to. But basically what we're doing when we're picking this floor, we're calling this 0. So when we go to face this part off, we're going to have a positive value, and we're going to take off the same amount as the positive value. It's pretty much going to figure it out for us. So it should work out pretty nicely. So we'll hit OK. And then right here, I just need to go plus 72. So this is going to be a 216. So I'll rename. That's going to be 216 degree index. And finally, the last one is going to be the one that's got this little 3D bit to it. So we do have to use a 3-axis toolpath on that. But I'm going to add my index. Now, there's two places I could pick. I could pick off this floor, or I could pick off this face. And I usually prefer to pick off the face, because then it knows that this is 0. So when we go to make our cuts for the depth of the, the depth we need to cut for the 3-axis and the depth of the inside, it's all based off this being 0. So this one will have a different depth when we face it off, but that shouldn't be a problem. So we'll hit OK. And then this one, I'm going to say rename. This is going to be the 3D surface index. I don't need to give it all the angles. If I wanted to know what it is, I could say plus 72 again. And so we'll do 3D surface, and then it's a 288 degree index. So 288 degree index. And then it should be 72. Another 72 will get us back to 360, which is technically 0. So the math works out there, kind of before we even got started. So that's great. So now what I'm going to go and do is face off this geometry right here. And I'm going to do that on all 5 sides before I start any other tool pathing, before I worry about drilling or anything like that. So I'm just going to right click on my top 0 degree index, and I'm going to go down to mill facing. Now, if you were doing the whole part, or you're doing a 2D part or a 3-axis part, something 3D, and you add a facing path, a lot of times you're just doing it to take away the extra stock that you have. And you actually don't need to pick the geometry, because it recognizes the X and Y extents based on the stock. But with this one, I am going to go and pick geometry. I'm just going to pick all 4 sides to this geometry. So I want to pick my wireframe and just pick all 4 sides to this, and then say recalculate. And what we'll see is the top of the part from the depth where we're at is at 0.6293. The total depth that we're going is 0.1. So I'm going to come in and say 0.6293. So it should take off the same amount to get us down to that level. Now we'll find out if our depths are good. We'll play around with it and see, but it should be going from the center, or from the index to the top of the stock with this one. It should recognize that stock. So we'll just go next. Right here, we'll use our top of feature and our total depth. They should be the same number. For the machining strategy, it's just going to go with facing. Right here for posting, we have work offset number 1. So that's my G54, my E1, whatever your machine calls the first work offset, that's what we're going to be using. Right here, we have our multi-axis posting. And this whole setup should be pretty well taken care of when you request the post and when we build the machine and do all that. Most of this stuff gets set up automatically. So we'll just run it that way. And then finally, we have our facing tool. So I don't want to use a 1/2 inch tool. I want to use something a little bit bigger. So I'm just going to go up to the tool crib, add from the tool library. I'm going to sort by the diameter, and I'm going to click it twice. And that's going to give me my big tools up top. So for this one, I'm just going to use a 1-inch flat end mill. 1 inch is fine. I could go bigger, but 1 inch will be fine. So I'll hit OK. And then I'll hit OK once again. From there, we'll just hit next. And right here, we have our patterns. So you can either do a zigzag back and forth across the part. That's really going to depend on the material you're cutting and the tool that you're using. You know, you're going to climb in one direction, and then you're going to move back in the other direction. Give me 2 seconds. Let me just shut down this chat that I got going on. Quit that. There we go. All right. So if you can't do both a climb and a conventional mill, then a zig is probably a better choice. Zig is going to make a cut, say a climb mill. It's going to wrap it back to the beginning and make another climb mill. And the final one is the adaptive. Now, the adaptive keeps a constant engagement as it cuts around the part. So it gives you a pretty clean finish. I've been using this a lot more lately. We just did a part on our own little machine that we have at the office, and beautiful finish with the adaptive. You do want to make sure you use leads with the adaptive. We had some areas where right in the center where it all kind of finishes, we had to do a little lead out to make sure everything was clean, but that's going to be dependent on the part. I think it's all going to depend on kind of what size you're doing and everything. Let's go ahead and do it as an adaptive. I mean, we're going to have a few passes on this thing anyway, but we'll do it with the adaptive. Another way of doing this that would recognize the stock a little bit better could also be using a 3-axis toolpath. We could use, say, like a 3-axis advanced rough. And that would actually recognize and trim the toolpath to the stock. We might end up cutting a little bit of air here with this facing pass, but I'm okay with that. For the step over, I'm just going to set it to 40% and then hit next. Right here, we have our bottom allowance. So this would be if we were going to come back and refinish this floor with a different tool path, maybe a secondary facing pass with a different tool, different feeds and speeds. Then we would want to leave an allowance. But in our case, we don't want to leave an allowance because we don't really need an allowance. This is going to finish right to the floor size. So the only big change I really need to make to this whole tool path is I don't want to take the full 693 thousandths in one pass. So I'm going to do multiple steps, and I'll just do it in 4 passes. So I'm going to take the depth of cut and divide it by 2, and then just hit next. Oh, wait, I got to get that to update, so then I'll just refresh. There we go. So we're going to take out about an 1/8 inch, a little over an 1/8 inch per pass. We're going to do 5 passes. So we'll go next again. Now for the leads, we want to use a parallel lead in. That's what I usually use. And then my rule of thumb for any time I'm messing with leads, just so I don't even have to think about it, is I usually just use half the tool diameter. So if I'm using a 1-inch tool, well, with the facing, it's a half the tool diameter or more, depending on which strategy. With the zig or zigzag, I might go a little bit more. But with this one, I'm just going to go with a 1/2 inch parallel lead in and a 1/2 inch, it'll pop up in a second, and a 1/2 inch parallel lead out. So I'll go next. Right there's our links. Because we're using the adaptive, we don't really have any links. The max link gap is a percentage of the tool diameter. Basically, if the tool path has to wrap it, or it encounters a large gap, it will wrap it instead of feeding across the gap. Now, a large gap for BobCAD, if that button is checked, is defined as 200% of the tool diameter. So if you have a gap in your geometry that's over 200% of the tooling diameter, in our case, a gap over 2 inches, then it won't, if it's under 2 inches, it won't rapid. If it's over 2 inches, it will rapid. You could also up the value to be more than 200% if you wanted to. Next, we have our advanced feed rate. So we can convert our rapids to feeds or change our lead in and lead out feed rate percentages. Now, the only thing I'm really going to talk about on this page is the convert rapid to feed. This is specifically for certain machines that have an issue called dogleg rapiding. Now, dogleg rapiding essentially changes it changes the rapid move. So instead of the rapid move being a direct straight line across your part, you'll end up with an angled line that gets to the x-axis before it gets to the y. Basically, all your axes are moving as fast as they can. They're not clocking themselves to stay in a nice straight line like they normally would be with, say, a normal G01 feed move. When you go into a G00, every axis on some machines go as fast as they can to get to the location. Now, there's no specific machine that does it that I could say there's a specific version of it. But the people that do run into this or that do have to deal with dogleg rapids are usually the guys that I've dealt with are running Haas machines. Again, if you ever see your rapid moves doing just a strange move in a weird kind of direction, instead of going straight to the corner they're supposed to go to, if they seem like they're kind of zigzagging out of the way, you'll want to take note of that. It usually, even then, if you do notice, it doesn't cause a problem unless you have some sort of fixture or something that the tool can run into. The only guys I've talked to that have had this issue that they actually had a problem with it were guys that did not use or were guys that had fixtures sitting above their parts. Bolt heads, there could be a lot of things, but basically you just want to make sure you're safe of any of your fixturing. So be careful with that one, or be careful when you're running. If you don't have a Haas, it's usually not a problem. And even if you do have a Haas, it's usually not a problem. But just be aware that what that option is going to do is it's going to remove any of those G00 rapid moves, and it's going to replace them with G01 feed moves. So that's all it's doing in the post. And again, most of you guys will probably never need it, but if you ever see some weird rapid moves, this features in pretty much every tool path of the system. So just in case you need it. When we're all done and we can't hit next anymore, we're just going to hit compute. And we'll see there is our facing pass. Now, I like to do all the indexes first, and then I like to do all of the tool pathing, because now what I can do is I can just copy this tool path, and I'm just going to go to the next side. I'm going to paste the tool path. So I've copied it. Whoops. So I've copied it from here just by right-clicking and going down to copy. And then I'm going to go down to where it says the 72-degree angle. And remember, you could click on the index to get a refresher on which one it is. And then I'm going to go ahead and paste that feature. Now, in some of the versions, 34 is still doing it. I can expand the 72-degree, and that's where you'll find your tool path right there. So I'm just going to do the same thing. Right-click on geometry, say reselect, and I'm going to go ahead and pick, not the whole face, but all the sides to this. Now, if we go in and we were to pick this floor right here, we should get that is the top. The depth, the amount that we're taking off is going to be the same as the last amount because we're centered on the part, but I don't have anything to pick off of right now. So for now, I'm just going to hit OK, and I'm just going to go steal the depth from the earlier one just because I need it again, and the system didn't pick it up perfectly. So I'll copy that. I'm just using Control-C, or you could right-click on it and say copy. And then I'm just going to edit this feature. I'm going to set my top of feature to the depth and my total depth to the depth. And then there we go. That's the same number of passes. We should be able to just hit compute. And there is our tool path, just like that. So again, we're going to then take that feature. We're going to copy it. We're going to shrink up the other two indexes. and we're going to go in and paste that feature under the 144 degree. Now we'll pick our geometry. Since this surface has no holes in it, it has nothing in it, what I can do is actually just pick that surface there. And then I'm going to go ahead and say that the top of my part is at the 6293, and the total depth is the 6293 once again. So I'll hit OK, and we're just going to go ahead and compute. It's the same thing every time. Wait a second. 144. Let me do this. Edit this. Pick top. The top of features. There. The top of features. There. And the bottom of feature. I don't know what happened there, but it dropped my geometry for some reason, or my depth at least. There we go. So compute that. And there we go. There's that one. And then finally, we have the last two. We'll paste the feature. We will reselect our geometry. This one I do need to go in and pick, not the floor, not the entire face like that. I need to pick just the outside edges because it has that inside pocket on it. So right there. So I'm going to say recalculate. See, I'm not sure where it's getting this 4-inch mark from, but again, I'll paste that there, paste that there, hit OK. And then something else, yeah, that looks good. So we'll compute the toolpath. Again, retract plane. I think it's resetting my height on this, so I got something to report later on. That's no big deal. And I'll go ahead and say compute. And there it is. So on the final toolpath, just going to copy this one and paste it. So for the final path, we're on the 3D side. The geometry is going to stay the same. I am still going to pick the entire outside edge of this. So here, 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 and here, and then I'll hit OK. And then I'm just going to edit that feature so that it has the top in the right spot. But instead of it being the same depth down that I'm cutting now, I'm going to pick my bottom as a different value. So I'm going to pick my bottom off of the top of this 3D surface. So it should still face the entire part off, but now we're only going down the 0.623. So that's 0. And then that is, whoops, so it's a 1/2 inch tall. So I actually have to do a little bit of math here. So the top is based on, so let's go 0.6293 minus 0.5. That's our top, and then this will be our bottom. So the reason I did that is when we create these indexes, what we're creating is the top of feature becomes 0 on that exact plane. And these are all the 0.6293. This one, I didn't pick this floor as my index system. I picked the top of this 3D boss. And that, from looking at some quick math I threw together, that's about a 1/2 inch deep. So yeah, that should be fine still. We'll hit OK, and we'll just hit compute. And we'll see that one's just going to go and face off the top once again. So now what we can do is, as we do this, with 4-axis, I like to kind of double check how everything's going. So I'm just going to go up and save this first. For me, anytime I load the simulation or I'm thinking about loading the simulation, I like to save my geometry first. And then say start simulation. That way, if something happens at this point, I don't lose everything I just did. So we'll say start simulation. And then for me, I can go in and say that I want to show the machine. And so this is what I was talking about. Like when we created this, when we create these rotaries, we don't put the jaws on them. So I'm not even accounting for the size of the jaws. All I've done is basically say from this front face here, I want to pull my part out minus 8 inches. That's where this whole thing comes from. Hold on one second. I have my flyouts turned off for some reason. So CAM, enable CAM tree flyouts, apply. Okay, there we go. So under the machine setup 1 here, where we have our work offset, I put that -8 in. That's to go from the front face of this rotary out to right there. That brings us 8 inches out on that part. Again, you might need to go more, you might have to go less, but really you should be accounting for the length of your part, the length of any extra stock, as well as the jaws. You might have a little extra, for the jaws. So from here, I'm just going to go ahead and say run. I don't want to go too fast. So you'll see there is my adaptive face pass. Now, what I'm worried about is the tool or the holder touching down there, but it looks like we got plenty of clearance. We'll know it because the whole simulation will light up red and tell us that we're doing something wrong. Also, on the report tab, you'll start getting reports anytime you have any collisions with the machine and the tool. So again, this is our first one. It's at 0 degrees. And then it should move to the second one. So for the second one, I'll go ahead and speed this up a bit. Got 5 passes on each one, just taking it to size. And there we have it. So I always like to inspect the part. I turn off the machine. I don't need to see it. Now I can see everything. So that looks pretty decent so far. We got a bit of cleaning up to do for the 3-axis, but we're going to do that with the 3-axis toolpath. So it's not a big deal. And really, for the rest of it, the 3-axis is the most difficult part. I'm going to go ahead and drill those holes. We'll do the pocket on the other side, and then we'll do the 3D. So again, basically, when you get into doing the 4-axis in here, you're basically still using all your normal tool paths. The only difference now is instead of right-clicking on machine setup 1 to add your features, you're going to right-click on your index. So for me to go to the correct index, I need to go to basically click on the index until you get the right one or know the name. So I got to go to the 72-degree one. And then I'll go ahead and expand that. And we're going to do our drilling right there. Now, I do not want to go in and pick all of the cylinder walls of every one of those holes. It's going to take forever. So to speed this up a little bit for myself, what I want to do is I'm going to add a new layer and just call it holes. And from here, I'm just going to go up to Create 2D and extract edges. I'm then just going to pick that entire surface there and hit OK. Now, when I do that, if I turn off my CAD layer, I'm now left with all the wireframe geometry for all those holes. So now BobCAD's going to know the depth of those, or the diameter of all those holes. But what I'm going to have to define is the depth, which isn't too big of a deal. Before I get into it, though, I always like to delete the outer border. I don't need that for anything. And then we'll notice a lot of these arcs are broken, which is fine because when we pick them, it's all good. But to clean up broken geometry, or what we could try and do is I'm going to go to Utilities. I'm going to go to Clean Up Optimize, drag a box over the whole part, and hit OK. And we'll see that that just fixed a bunch of entities. So now, instead of having 2 pieces, they should all be 1 piece instead of 2. Again, that really doesn't change anything, because if you were to pick the geometry with it being broken the way it was originally, BobCAD would put the arcs together and kind of know that it's not 2 drilled holes per arc that we pick. But again, Clean Up Optimize, it's such an easy function. There's never a bad time to use it. Whenever you're working with wireframe geometry, remember that button, because it's something you pick it, you drag a box over all your wireframe geometry, you hit OK. If it can fix something, it will. If it can't, it won't. So it's kind of one of those features I use anytime I think I'm doing something wrong. I'm going to go ahead and just hit save, just to be safe with everything. Give it a save, and then we can go back into our feature. So right here, I'm just going to right-click on the 72-degree index, and I'm going to go down to mill drill hole. Now, we also have a feature for hole recognition, but I usually, if I'm doing an index, I like a little bit more control for myself. So I'll usually do my not mill tap hole. I'll usually do my own mill drill hole on that. So I'll select the geometry. Again, just drag a box over all those holes, just like that. Now, at this point, I want to have my solid model turned on because I need to come in and tell it what to use as the top and all that. So if I say use as top right here, it's going to use the holes that I selected as the top. That should be 0. As far as the depth goes, I don't define that here on this page. Like with 2-axis, I get to define the depth on, well, as I'm picking the geometry. But with drilling, when we hit OK, we can actually come in and say pick bottom for the depth. Now, when it comes to picking the bottom, it depends on your model. In my case, I just have these kind of cylinders with a flat bottom, but realistically, they would have a point in the bottom. It's whatever the drill tip angle is that I drill these with. Some of you guys get your parts with that kind of geometry in it. And there is a benefit to having the drill tip pointed there, as you know exactly where you need the tip of the drill to stop. So later on, when we see our depths that we end up going, if you know the tip, the depth at which you want to stop drilling, you can just enter that in for your overall distance. For me, though, I'm going to let BobCAD factor in the depth of the tip. So I'm going to pick that arc right there and just hit OK. And so we'll see it actually is just a 1/2 inch deep. Now, right here's a little button, and if you forget to check it at this point, it's not a big deal. It's on the next page as well. But there's 2 types of holes you're going to drill. They're either through holes, meaning they cut all the way through, or they're blind holes, meaning they don't cut all the way through. So if I uncheck through hole, it means I'm using a blind hole, which is what these are. And the difference between the two is if through hole is checked, whatever your depth is, we're going to add 50 thousandths onto it. So in my case, I just want it to factor in. I want a full diameter cut, a 1/2 inch deep, and I want it to not add any extra. The only extra I want added is the tip. So we'll go next. Right here, we have our group. I'm fine with all that. For the strategy, I'm going to choose hole. And normally it gives you a center drill and a drill. I accidentally deleted my center drill out of my defaults a few days ago and haven't added it back in. So I made it look the same. It should be a center drill and a drill. And then I'll go next. For the sequencing, I like to use optimized. Essentially what optimized is doing is it's looking at how it would order it for closest or pick order or the X or Y direction. And it picks the most efficient one of those 4. Now, it doesn't use custom direction because custom direction lets us set an angle, and it could be any angle 0 to 360. So it doesn't check with that one. And you can tell which corner to start closest to, which hole do you want to start on. So right here for the posting, we have our, again, work offset number 1. We'll hit next. For the multi-axis posting, this should all be set up once again. And then right here, we have our center drill. Now, I don't usually like to use, I don't use center drills a lot. I use spot drills more often. If you want to use a center drill, feel free. Otherwise, you can go to your tool crib and add from the tool library. Now, what you'll see is you have your standard center drills up top. We also have a bunch of spot drills down at the bottom. So for this one, I'm going to go with I'll just do a 1/4 inch 90-degree spot and hit OK. Now, what we have is a really easy calculation for if we wanted to do chamfers or anything. So if I go ahead and hit next on the center drill, if you wanted to add a chamfer to these holes, what you could do is set the center diameter here in the middle to a little bit larger than the diameter of the hole. The holes we're cutting are 1/8 inch. So if I wanted to do a little chamfer, say a little 10-thou chamfer, I'm going to say that I want the center diameter to be 0.135. Now, BobCAD is going to automatically do the math to calculate what that distance needs to be depth-wise to get us that center diameter. So when we watch the simulation, we should expect to see all of these holes have a little chamfer on the top of them. We could also peck our way out. So you can do a peck or a fast peck inside of the center drill. For the drill, just going to go with the 1/8 inch drill. BobCAD always picks a drill that fits the diameter you say. The problem with BobCAD picking tools a lot of times could be that the material that the tool is made out of is wrong. In this case, it's high-speed steel, and I could do it with high-speed steel. But it all depends. You know, you got to make sure that the drill that it chooses and the feeds and speeds that it chooses are for the material you're setting up. So right here's our parameters. So, oh, I left it on. So what you'll see right here is our depth that we have set up is a 1/2 inch, but you'll notice this effective depth is set to 0.55. That links back to this page back here. I forgot to switch it back to blind after talking about it. So when I go back to the parameters now, you'll see the effective depth is a 1/2 inch. This overall depth, this is the number you're going to see inside the G code. And that's the depth that we need to cut for a full width plus 37 thousandths to account for the tip angle. And I believe I'm using a 118, so it's taking that into account. And then for this one, I'll go ahead and say, yeah, let's go ahead and peck it out and then just hit compute. And there is our drilled holes for all of those. So now what I'll do is I'll do this 2-axis pocket we got here. And I made it with sharp corners. This thing shouldn't have sharp corners. A quick update you can make to this is I'm going to finish it with, I'm going to use a 1/2 inch tool to rough it and a 1/4 inch tool to finish it. So a 1/4 inch tool leaves an 1/8 inch radius. So I'm going to set my radius to an 1/8 inch. And then I can actually go in and pick these inner walls here. Here, 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 and here. Whoa, there we go. Come on, we can do it. There we go. And then I could say, show me my preview. And it should be able to add those fillets onto the corners. Now, if you didn't do this, you don't have to do this. There's really no benefit to this. If I go in with a 1/2 inch tool to rough it and a 1/4 inch tool to finish it, that 1/4 inch tool can't cut a sharp corner. It's not going to try and shove it even further into the corner. It's just going to go and basically leave this exact pocket. But now I have a proper representation of on my solid model of what I would expect to get when I run this my normal way. So for this one, we're just going to go down to the 216-degree angle index. We're going to do a mill 2-axis. Select geometry. I'll just pick the floor of that one. And on this one, I'm going to say pick top. Well, the top is going to be right there on the top edge because we face this off. And then we're going to go to a total depth of 1 inch. So we'll go ahead and hit OK. And then go next. For the feature, really not much to change here. I'm not going to use extensions really anytime I do a closed shape, and I can't think of a time I'd use them on a pocket anyway. Usually that's something you'd use on the outside of a shape. So we'll just hit next. Right here, we'll choose pocketing, which gives us a pocket and a profile finish. And then we'll go next again. We got our tabs, multi-axis posting, posting and then multi-axis posting. Right here, we got our 1 inch tool. I'm going to just make this. I'm going to change it from a 1 inch to a 1/2 inch. A 1/2 inch flat rough end mill standard. And you'll see that the flute length is 1 1/8. So that is long enough to cut the 1 inch deep pocket we need to cut here. So we'll go next again. Right here for patterns. Now, I really don't use the standard pockets too much anymore. But if you're looking for a really fast calculation, the standard pockets will always calculate pretty much instantaneously if your computer's any bit decent. The advanced pockets can do more, though. So the whole thing with the advanced pocket is maybe you want to do an open pocket. The standard toolpath can never do open pockets, but the advanced pocket can. And the advanced pocket has a lot of the same settings as what the standard pocket has. So a lot of times, if I know I'm going to be making more than one, what's the best way to put it? If I know I'm going to be making more than one pocket, then I like to use the advanced pocket because then I can set all my settings the way I want and kind of make it work. So I'm going to do that. I'm going to go with a offset pocket out. I'll go with a 40% step over. For the parameters, I'll leave 15 thousandths on the wall. That's all the 1/4 inch tool has to worry about cleaning up. Go next again. Or sorry, not next. I want to do some multiple passes with this. I'll do 200 thousandths. Next again, we have our leads. How do we enter into the material? With this one, I'll give it a little ramp entry. The length of it is going to be a 1/4 inch. So it's going to move back and forth along a 1/4 inch and just ramp into the part. Machine sequencing, I always turn on optimized. It really doesn't matter because we're only cutting the one pocket, but I always turn it on. Links, I'm just going to go direct from one cut to the next. And for the advanced feeds, we're not converting any feeds and speeds or rapids to feeds. We're not changing any linking feed rates, and we're not doing any adaptive. This corner slowdown isn't used too much with milling. That's more for your laser plasma water jet to slow down in the corner and kind of straighten out the stream of plasma as you round corners. So we don't need anything there. We'll go next. For the finish tool, I'm just going to set up my 1/4 inch flat end mill. Just make sure that the flute length is long enough to cut the 1 inch deep pocket, which that one is. Right here for the patterns, we have compensation to the left by default. This is just my offset direction. Left is going to be a climb mill as long as the direction of your cut is set correctly. So I'm going to go with left. And then with the finish path, I always like to give myself a G41. I'm already going to have leads on the part, and that's really the only stipulation for using a G41. So I'll go next again. It's a finish pass, so this one's just going to get no side allowance, single depth, just take off that 15 thousandths we got left. For the leads, I'm going to go with a circular lead. And my rule of thumb that I always follow, again, is half the tool. So I'm going to go with an 1/8 inch, which is probably smaller than it needs to be, but it should work. Next, again, we have our corner types, no changes there. Machine sequencing, turn on optimized, and advanced feeds, no changes. So we'll go ahead and hit compute, and there's our simple little pocket right there. We have our start point, there's our finish pass there. So I'm just going to go ahead and hit save. Oh, and I wanted to point this out. I just figured this out last week. Some of you guys might deal with this once in a while. Right now, if we just blank this feature out, and I look at my finish pass, I'm just going to say backplot. So normally the finish pass, it plunges in, it cuts around the part, and it exits out when it's done. Some of you may have heard of spring passes. Now, we have no real good way as of now to do spring passes, like a button check that you're going to just say do spring passes. I've requested it. They are working on it. They're trying to figure out how to implement it from what I understand. What I figured out last week is if I look at this profile finish right now, and it sounds kind of strange, but if I look at it, I can see the total feed distance, about 12.55 inches. So what that means is that distance that we move for our lead and all the way around is a little under 13 inches overall. So what I'm going to do is I'm going to edit this feature. I'm going to go to the leads tab. Now on this overlap amount, normally if I just say, give me an overlap of a 1/4 inch and I hit compute, from where we let in right there, we're going to cut around the part and then lead out. What I found though is if you add, so if we go to our leads and we make it just a much larger number, say 20, and I hit compute, you'll see that the lead goes back to its original position. Again, this is not true spring passes because I only get one extra pass, but now when I go to do my finish, when I backplot it, it's going to go around, lead in, go around, make our cut. Normally this would be when we lead out, but it's going to continue past that. It's going to overlap past that and back all the way around and then lead out. Basically, from what I understand with the rules of this one, is if you use an overlap amount, it can be anywhere along that chain, but it'll stop when it gets back to the start point, to where it needs to lead out. So technically, when it comes to setting up a distance for this, I don't need to go take measurements. I could just put a ridiculous amount here. Even if I put 100, the pass is still only ever going to go around. Oh, wait, it went 2 times. Hold on. We just figured something else out here. Back plot. We got our 1 pass there, 2 pass there. Then it leads out. Okay, I just miscounted. That was my fault. So yes, 2 passes. It gives you 1 extra finish pass. And the benefit for me and why I like it a lot, since I started using it just literally like a week or 2 ago, is it doesn't lift up the tool. You know, normally the way we have to do spring passes is basically copy and paste the finish pass to run the finish pass over and over again. But that one will have the lead outs applied to it. So it'll lead in, make its cut, and lead out, lift the tool, and then plunge back down, lead in, make its cut, and lead back out. This one, you're keeping the tool down at that level the whole time. So it's something that now if I was to do this and I was to say copy this finish pass and then paste it right below that, now I can compute this. And now I'm technically doing 4 passes because the second one has that overlap amount as well. So, you know, spring passes, I'm hoping they do something here in the future to make it a lot easier. But for now, that's a little workaround that I figured out, just a few days ago when working with one of the customers trying to get just an overlap, and we ended up making it so large that it did 2 full passes. So I'll leave that spring pass I got on there. So now what we'll do is let's give that a save. We finished making some tool paths. It's a good time to save. And then we're going to go ahead and launch the simulation and see how all of our 4-axis with the 2-axis is going so far. All right. So we'll see that the machining order got a little messed up on here. So I'm going to fix that first. I always do this, close the simulation and then change it. Making changes to toolpaths while the simulation's open doesn't do anything. You still have to close the simulation and reopen to see the new changes. So I'm just going to go ahead and say machining order. And for this one, I'm going to go with individual tool and hit OK. But just be careful. Make sure everything looks good. This one should do all the facing, then the center drill and the pocket and the profile. So looks good. We'll hit OK. And now we can go up and start our simulation. And now it should show the correct results or in the right order. All right. So right here, we're just going to go ahead and I'll slow this down just a little. Actually, I don't need to run any of that. We'll just fast forward right to the center drill here. And then we'll see. Let me turn off my workpiece. So I'll hide that. And we'll see right now, it's just going to go in and start doing a center drill on every one of those holes. Now, another thing, I just had a guy in a training earlier today that got thrown off by this, but when you're creating or when you're watching the simulation, a lot of times the quality is just dropped very low. And that's really just so we can process everything, so it can handle everything. My computer's pretty decent, but some of you guys, your laptop might struggle with simulation as it is. All you got to know is when it's all done, it will kind of clean everything up. So I'm getting some little collisions here between a stock and let's look at the report. Whoops, didn't mean to take the whole menu there. Look at the report tab. So the stock and the flute. So it's plunging in and probably encountering, I know what it's hitting. It's hitting the floor down there that we had. So that's no big deal. Okay, we can deal with that. And then it's going and doing the pocket on the other side. And again, when it's all done, that's where we can go and start inspecting the part. So that was my 4 spring passes at the end of that. And now it's going to clean everything up so that when we do zoom in on these holes, you just wait, you'll see a little thing right there, automatic quality improvement. And that's going to be our little holes with our little chamfers on it. So it looks pretty good. All right, now for the 3-axis. And this one's really all about just figuring out the tool path you want to use. Now you could do it all with 3-axis. I'm going to do it with an open pocket and then come in and finish it with 3-axis. So I'm just going to right click here and say open pocket. And then I'm going to do another one and just call it pocket, because I'm going to do this as the outside open pocket, and then I'm going to rough out this inside shape as well. Actually, if that pocket's perfectly vertical, we should be able to just use a 2-axis. Let's find out what size radius we have in that corner. Hopefully it's an 1/8 inch. Perfect. So we could actually use the same toolpath we used before for that inside pocket. So I'll do that real quick. We might need to change our roughing tool. So I'm just going to copy that feature 2-axis and paste it under the 3D surface one here. So I'm just going to paste that right there. And do you want to use the same top of feature and depth? Sure. It doesn't really matter because I'm going to come back and repick all that anyway. So I'll say geometry is just going to be that floor right there. The top of it is there at 0. The bottom of it is, let's see, 1 inch deep. So that's all fine. We'll hit OK and try and compute it, but I don't think the 1/2 inch tool is really making a way down in there. So if we look, let's blank that out. That's what it's doing with that 1/2 inch tool, just zigzagging down there. Actually, it's not too bad, but I'd be more comfortable doing this with my 1/4 inch tool. So I'll just go ahead and pick my 1/4 inch. It doesn't matter if it comes from the end mill finish category or the end mill rough. It's just an end mill. And just going to make sure I'll do a 40% step over is fine. And I should still be doing my ramp entry. So I'll hit compute. And now we'll see there's our pocket. We have a few more passes in there. And then we have our profile finish. Again, and because I copy and pasted the toolpath, I have those extra finish passes as well. So that was the pocket. I actually didn't need this layer at all because we didn't do anything. But for the open pocket, I'm going to go in and extract some edges. So I'm going to go create 2D, extract edges, and I'm going to pull the edge off of right there. And then hit OK and cancel out. Now the pink that's showing up, just so you guys are aware, that was me accidentally clicking on the facing feature. It's trying to show me the geometry that was picked. So just got to click off of that. But now if we turn off all of our other layers and we blank out all our toolpaths, we're left with this wireframe geometry. Now for the 2-axis pocket, the easiest way to do an open pocket is if you know what edges are your walls. So in our case, don't know how that got moved, but so in our case, we want to treat this edge as a wall. The tool's not allowed to go into it, otherwise we'll take off too much material. And so this is going to stay a solid line. The outside shape, this rectangle here, we're going to change that to a dotted line. So I'm just going to pick it, right click, modify attributes, line style, and then I'll go ahead and choose dotted. Now this will allow us to paste our toolpath again. It'll say, do you want to use the same top and depth? Sure. And we'll go and pick our geometry. Now, basically what we're doing is we're saying, I want to machine everything inside that piece of geometry for the pocket, but I want it to stop when it gets to here. So again, I like to turn on my solid for this so that I can pick my top right there. I can pick my bottom down to here. And I could also come in and check my start points. The only part of this toolpath that's going to have a finish pass, which honestly, we really don't need it anyway. But the only one that's going to get one is the solid line. So I'll go ahead and put my start point there. This outside dotted line shouldn't have any finish pass applied to it. So I'll hit OK. And then because we used the advanced pocket earlier, I can actually just compute this toolpath. And there is my open pocket. Now, really, I could go in and I'm going to say on the machining strategy page, I'm going to get rid of the profile finish for both of them. And on the pocket, the only change I'm going to make, same tool, I'm going to change to a 0 for the side allowance. I'm going to just let this tool finish it. I'll do it in 2 passes. We'll go 1/4 inch per pass. That's fine. Actually, we'll go about 200. We'll do it in 3 passes. Keep it the same. And then compute. So now we have it getting finished as if this wall was vertical. And now we need to apply a 3-axis toolpath to clean that up. So again, we right click on the index system we want to add it to, and we do our mill 3-axis. So for this one, I'm going to say select geometry. And just like the rules, if you're doing a standard 3-axis job, you're going to pick the entire part. Now, it knows where it's looking because of the index system. It knows what to look down on. The boundary I'm going to select is going to be just this outer edge right here. And I really should blank out that toolpath to make it easier. But I'll pick all 4 sides to that. And then I'm also going to go in and pick this edge right here, this top edge. And I want to speed this up. So I'm going to hover over the edge and right click and say constant Z, and it'll grab the whole thing. Again, to do that, you just hover over the edge, right click, and then if it's all on the same Z level, use constant Z. If it's all part of the same loop, use loop selection, because sometimes the Z level is not, it doesn't align with the Z. So the top, we're going to say pick top. The top is right here. We've already machined it down to there. So it now knows that the top is at 0, and I'm just going to hit OK. Now, the best toolpath to really finish something like this is going to be a Z-level toolpath, either a Z-level finish or an advanced Z-level finish. I'm going to keep it simple and use the toolpath that I'd say most of you guys would have. If you got the up to 4-axis standard, some guys don't get the 3-axis Pro, which is totally fine. I'm going to go with the Z-level finish there. Next, we're going to choose Arc Fit. Now, we want to make sure to turn this on because this is what's going to tell BobCAD to use arcs inside the final G-code program. Right here, we have our multi-axis posting, whatever. And right here, we get to our tools. So I'm going to go ahead and use, let's do a, we'll go with a 1/4-inch ball. Actually, we'll go with 3/16. Remember, you could type the fraction directly in, or you could just type in the 1875. The big thing, though, whenever you're doing your corner radius, the easiest way to get the corner radius correct the first time is to type in your diameter and divide it by 2. Let BobCAD do the cutoff on the values so you don't lose so you don't lose that little bit of information. The best example is a 1/16 of an inch tool. When I do a 1/16 of an inch, what I need to type to get the corner radius to come out properly is 0.03125. The problem is a lot of guys don't write that. They go out there 4 places, so they put 0.0313, which is not fine. Even though if you look, 0.03125, if you look, they're the same number in the corner radius depending on how I do it. If I go in and I type 0.0313, then BobCAD has to use that number. And if you multiply 0.0313 by 2, you end up with 0.0626. So when you run the simulation, you'll get an error telling you that BobCAD can't construct the ball end mill that we use. So that'll be the problem. So what I always do when I'm setting these up is take the diameter, divide it by 2. That way it is calculating out to really however many decimal places it needs, but then BobCAD's going to truncate it. If I was to go show 5 decimal places instead of 4 right now, that number would show 0.03125 instead of 0.0313. All right. Again, not that big. No. Yes, it could also be a good idea to increase the digits. I use 4 decimal places. That's all I really ever have to go out to. So for me, the easiest way to define any ball mill, and I'll do this on 1/4-inch tools, it doesn't matter, type in the diameter, divide it by 2, let BobCAD do the truncating, and it all works out. All right. So for this one, I'm going to go with a, 1/4-inch ball. We'll go with a 1/4-inch ball. And next, again, we have our patterns. So on the patterns, we're just going to do a climb mill. There's not much to this toolpath as far as patterns go. For the depth of cut, we do need to give it a good enough depth of cut that it can clean everything up, but we don't want to be too aggressive because there is a little bit of meat still left on the corner. So I'll go with a 20 thou depth of cut, and we might actually have to come in and rough this out a little bit as well beforehand, but we'll find out. The allowance, I don't want to leave any allowance. I want to finish right to the surface size, and then I'll go ahead and hit next. Right here, we have our leads. I'm just going to plunge in vertically. We'll try that. Might use something like a circular lead or something like that, but for now, we'll try it out. Basically, when we're going through these toolpaths, try and leave as many of the defaults as you can, because if I don't have an issue with them, well, then I don't have to think about it. But if I do see a problem with them inside the simulation, I could always come back and make changes. For the cutting extents, we have a boundary that's telling it what we want to cut, so we shouldn't have to set anything there. We're going to process by area off the tool tip. The links, again, going to use the defaults. If I see a problem, I'll come in and change it. When I'm done, I can't hit next anymore. We'll hit compute and just give it a second to calculate. And there it is. Now, Mark just brought up, will there be a small cusp at the bottom? Yeah, there probably will be. A lot of that's going to depend on the tool that I use. You know, the smaller tool I go with, the better the finish is going to come out. I don't know what it'll be with a 1/4 inch. It should be pretty, I think it'll be pretty decent. What did I do for my depth of cut? A 10 thou? 20 thou. So I think I'm going to go with 25 thou. The reason being, I have a 1/2 inch height here. 25 thou breaks down evenly into a 1/2 inch, where my 20 thou, I guess my 20 thou did too. No, we'll keep it at 20 thou. That should naturally just end at the bottom. And this is the best way to use one of these Z-level toolpaths. If you can calculate the depth as a factor of whatever the thickness of the part is that you're trying to do, you'll get the tool to end up with its final cut on the floor, which is one of the biggest problems with the Z-level, is not getting that final pass on the floor. So we'll see. We're going to run the simulation here, Mark, and find out if this is close enough or if we have to go in and get the radius. We got to tighten up that radius as close as we can. Or you'd have to use some sort of tapered tool, V tool, to really clean it up. But yeah, the cusp is going to be there because the center of the tool hits the floor. But for it to really clean up that bottom radius, it needs to go deeper than the floor. But that's why hopefully the pocket will clean it up with it. So we'll give that a save and try it again. Let's see what the simulation gives us. Yeah, you could add a chamfer to the radius of the part itself, and that would actually keep the finish pass away as well. So we look at we looked at all that. So we'll get right here to the pocket. This pocket right here is the one we want. No, yeah, wait. Where's my other pocket? Did I get rid of the wrong thing? No, pocket. Oh, it already did it. Hold on, let me restart this and go down to this pocket. So again, right now it's grouping the tools together. So it's going to go rough this pocket out on the side here. Let me just hide my tool path. So it's going to rough that pocket there first. And then it's going to switch and start machining this top. So that's that open pocketing that we have. Finish pass. And then it's going to go rough that inside pocket. Finish it. And then there's our Z level. Now it's a little aggressive because we do have a bit of meat left on there. But we could change that. And yeah, the way to fix this lip would be to properly add a radius into there or use a smaller tool. I could go in with, let me copy this and paste it here. And then I can edit this feature and say on this second one, I'm going to switch to an 1/8 inch, with a 16th inch radius. Oh, not divided by 0, divided by 2. And then on the top of job, if I say pick top and I pick this edge right here and hit OK, it'll tell me that that's at 0. So I'm going to tell it to start minus point, say 375 down. And then the bottom of job is going to be 0.5, the total depth of that pocket. And with this one, you could go with something like, instead of going 20 thou, go 10 thou, because we're only going to be cleaning up that little section. So I'll hit compute. And, well, wait a second. Thought it'd be faster. And now let's go ahead and blank out these features and see. I guess I didn't go, let me edit that. Oh, there we go. There's our problem, minus 0.5. I didn't put the minus value in. So finish and compute just that one. There we go. So that's going to go in a little bit deeper. It's still going to leave that a tiny little lip on there. Again, Mark said it already. The best way to do it on our original model would have been to add the fillet to the model, whatever's an acceptable size fillet. And then really the way I'd want to run that is on that open pocketing. I'd try to use something like a bullnose end mill that has the radius of the corner in it, so that when I do the finish pass or when I do that floor, it does leave me a nice flat floor, but I could also get the radius into it before we blend the rest of the wall into it. And honestly, it's one of the biggest fights you'll have whenever you use the Z-level toolpath, how to get the floors and the walls to blend together nicely, because you are limited. You're using the tip of the tool and all that stuff. So again, I'll go ahead and hit save. And I just want to look at the machining order before we simulate this. And so I'll go individual tool, okay. And then we have pocket, and then this is using the same tool. All right, so we're running the same tool the whole time. I'm not going to change the order of how it runs to make finish passes and tool changes happen and all that stuff. So again, give it a save and then launch the simulation. The worst thing is when you go to launch the simulation and you didn't save it, and then BobCAD locks up for some, whatever reason it locks up, and you lose the work. It's especially working with 3-axis. I save so often. So we'll go ahead and run the whole thing pretty quick this time, and it's going to just face everything off and do the runs. So I want to look at, I believe this side is the one we want to orient up. That's what we'll have up. There it is. So you'll see, even with the smaller one, we still have a little radius. Again, right way to do that, add whatever acceptable fillet you could put into there, or you'd have to get a tool that matches that taper and has a flat bottom, but I'm not going to calculate all that. So there it is. That's our part. So now what we could do is we'll close out of the simulation, and we're just going to post our code. And the way I like to do this, to first just check my initial, rotations on everything, I'm just going to post the facing toolpath for now. Just the facing for all of these. That way I'm not sorting through all the code. I'm looking at just bits and pieces. And if I post my code, we'll see there's our A0, and that should be aligned up with our Z-axis already. Because I oriented this part so I had at least a flat surface here. And so that gives me if we look at our origin, that lines us up there, and our index aligns perfectly with Z. Again, the reason I make sure to do that, even though I really don't need to, is because if I didn't have this thing perfectly square to that face, maybe there's a 1 or 2 degree angle, this is going to recognize it and make sure that everything else gets cut according to that. So we have our A0. We'll scroll down. We got all of our facing, and this is the adaptive. So it is a lot of code. And I'm doing multiple passes. If we were doing just one, it'd be even faster. But we're doing, I think 4 passes per face. So there's a lot of code here. But we'll just got to get down to the next one. You could open this up inside a notepad and look for, different things as well. Look for your different depths or whatever. Because my goodness, is this thing longer than I was expecting. I feel like we're getting close, though. Real close. There we go. So you'll see there's our G54, so we kept the same one. There's our A72. And so if I go ahead and say, let's open this up inside the NC editor. we can actually do a find and just search. And that's really all we're trying to do is say find. And let's go find an, A0. So we'll say find next. So now we could go find whoops, I got caps lock on, that's what it is. So A72, find next. There's our A72. We could then do our A144, find next. There it is down there. So all the numbers we calculated and everything we did came out pretty good. So there we have it. Close that down. So I'm pretty confident in what I did. Now I go in and post my entire job. Before you post, again, double check the machining order. Make sure it's the order you plan on running everything in. You might need to move some things around. Maybe I don't want to do the drilling at that point. Maybe I want to save that till the end. It's however you want to decide to do it. So there we have it. Any questions so far? Anything for indexing? We're going to go create us a little wrapping real quick and see what we get. So let me see. Mark's got something here. Had a question regarding setting angle. I want to cut vertical parallel walls on a cylinder and a rotary, but I want to cut from the same side of the cylinder. So don't let the post lift up. So basically with that one, you want to force specific rotate. So you want to cut okay, so if I'm understanding this correctly, I'm going to use this part to kind of show it off. But basically, if I had a parallel wall here and a parallel wall here, you want to cut both of them from the same index, correct? Is that what I'm getting? Yes. So you're going to have to find the index that those two would share. So just what I'm going to pretend is that from this edge right here, it's going to go straight down. We have a parallel wall. And from this edge, we have a parallel wall. So the index that I'm going to use is this index here. That orients my tool to that location. So now I'm just going to say, let's do a mill 2 axis. We'll select our geometry, and I'm just going to pick both of these cuts. And then I'm going to set my direction. So this one's fine. This one I'm going to flip. So, oh no, I need to flip them both. There we go. So this one compensated to the left is going to put us on the outside and cut along that wall. And then that one will as well. I'm just going to say pick top. And then for the total depth, I'll just say 1 inch. Now it's going to gouge like crazy. We're going to see a bunch of weird results, but it should work. So from that one side there, I have my 2 chains. We're going 1 inch deep. I'm just going to do the profile rough and profile finish here. And really, the only thing I'm going to do is set up, we'll use our 1/2 inch tool for this. Yeah, that's fine. I don't even care about multiple passes. I'm just going to do a little parallel for the leads. And then for the finish tool, yeah, that's fine. Use the 1/4 inch. And then once again, for the leads, we'll go parallel. So when I hit compute on this, you will see those passes that are now down in that wall. So if I turn off, let's turn off everything else. So we're just going to face this off. You know what? I'll turn on the facing for, we don't need it. So let me just hit save. Basically, you want to find the index. You just need to find either a surface or you might have to go make a UCS. So it needs to force a rotation. There's no real way to force the rotation to happen. This is all from the same axis. It lifts up and moves over. What do you mean? You can't? The spindle moves up in Z and over in should be Y. So the only place that you could specify an angle would be on inside the posting tab. The problem is the simulation does not show this. It's this output rotary angle right here. And what you'd do is you'd program like one of them. So if I was to do this again, I would, let me just do, here, let me post yes, no on that. Copy that, paste that. Yes. So let me try this out and see if I get it. So the geometry, I'll say reselect. I'm going to get rid of this side over here. And I'm just going to cut that one side. hit OK and compute. So there's just that one side. Now on this one, I could pick the same side. Now the direction might be messed up because of how we're about to do this, but I'd flip it so that to the left puts us on that outside. And then inside the actual feature on the posting tab, you'd have this output rotary angle and you would tell it to go 180 degrees. Now I may have picked the wrong line. Now the big thing with this is it does not show inside the simulation. All you're doing is specifying the angle that you're rotating. So if I hit compute on this, I end up with the same looking part. It's not rotated 180. But if I was to, let me do a post yes, no on everything, but we'll just do the 2 finish passes and post my code. There's my A0 right there, and then there's my A180. Again, the problem with this is you will not see it inside the simulation. The only place it's going to show up is inside of the code there. If we were to run the simulation with it right now, and I'll turn on my facing, I'll just turn on the whole thing here. It's going to look as if the tool just lifts up and moves over. Unless they fixed it. I don't use that output angle range really ever. So let's find out. So we're just going to face it off first. And then I'll slow it down when we get near the end of this thing. So there's our first cut, which is technically right. And then there's our second cut, which is technically right, but in the code you would get that A180 to output. So yeah, it's not super common. I have a couple guys that program that way, but for me, not being able to simulate it always gives me a hard time. Okay, so you're saying you do this to check your distance for your Y. That makes sense. Yeah, definitely. Then that's a perfect use for it. Be able to take your measurements. Again, you can't see it in the simulation, but as long as you know what you're supposed to be measuring, or you should have no issues with that. So, cool. All right, so now let's do us, what time is it? How much time we got left? About a half hour. We can knock out a quick wrap in this one. So I'm going to just do it on the fly. I want to show you guys how I figure it out, and we'll just do some quick text and wrap it around a cylinder, but I just want to go through it a little bit. So I'm just going to open up a new window here and shrink down that posting tab. Now, the first thing I have to do is kind of determine what size am I trying to wrap around? What do I want to wrap around? And I'll do it. It's going to be a 3-inch diameter piece of stock that we're going to use. All right. So before I even get started making anything, what I like to do is draw out a 3-inch diameter piece of stock. Now, the reason I draw it out in wireframe first is strictly so I can take a measurement of it. 1 second. So Mark said maybe I'm remembering some angle control in the premium 4-axis toolpath. Yeah, there might be. There's definitely more options. Give me 1 sec. We'll go back to the wrapping. There's definitely more options when you get into the 4-axis pro toolpaths. Like these ones. I could go with 4-axis, and then there's things in here, limit by angle ranges. There's you could. I mean, really, that's about it. Most of the limits for the machine, most of the time when you're dealing with limits, it's going to be for, or really, it's the machine that really kind of defines all that stuff. But like right here, you could do an angle and set your tilt and lead angle and all that stuff. Your U-axis, or do you mean a Y-axis? A or U, so yours calls it A. Yeah. So the way we define it for the axis is what axis are we rotating around when we're doing it. So for us, everything's going to be A, B, or C, or really it's X, Y, and Z. But again, the machine is going to really be the thing that sets the limits for a lot of this stuff, other than There's a lot of options here. Be tilted with an angle, a specific angle, or tilted with an angle, a fixed angle to a certain axis. So there's a lot of options for that, but yeah, you got to figure out which one's kind of needed at which point. So, all right. So now, jump back over here. So again, I drew out myself a 3-inch diameter. And now what I'm going to do is go up to the Evaluate tab and say Measure 1. And I just take this measurement and scroll down to the bottom, and right there we have our total length. It's my lazy way of not having to do real math. But all I'm trying to figure out is the circumference of the arc. And if I know the circumference, then I now know the length in which one full rotation of that part equals. And in this case, it's 9.4248. So I'm just going to go to my CAM tree, and I'm going to draw this out first. Actually, I don't even need to really draw out the stock. So first, I'm going to go ahead and make my stock. It's real simple. I don't even have to define anything. I'm going to go with my 4-axis mill, just like before, right there. And I'm going to do my stock wizard. So the two numbers I need to know is the diameter that I want to make my stock. So I'm going to say it's 3 inches. And how tall is the stock? I'll say it's 5 inches wide. Now, right now, it's in the wrong orientation. It's lined up against with the z-axis here. But if I say x-axis, it'll rotate that. Now, the other change I like to make is I like to shift my stock and do all my work in this upper right-hand quadrant, really, because I want to use this origin on this front, this front face here. So my length of 5 or my height of 5, I'm just going to say in X, let's move over 5. And so that put the front face of my part right on the origin, which is what I want to use as my origin. So it works out perfect. So I'll go ahead and hit OK. All right, let's pull the stock out. We'll do the same, -8 like before, and hit OK. So now what I can do is that's my stock, and really anything I want to draw, I'm going to draw it out flat. All right, but how do I know how much to draw? Well, that length right there is the circumference of this part. So the way I do it is I draw out a rectangle. And I draw out this rectangle with a length in X as the width of our part, so 5 inches wide. Or sorry, the length is going to be, we're rotated. So for X, we're going to label it as the height, this, of our part. For the width, we're going to enter in that value there, the 9.4248. I'm then going to take the bottom left-hand corner and put it at XYZ 0, right at our origin. And I'm going to go ahead and hit OK and cancel out. Now, what that rectangle represents, all right, let me blank out the stock. What this rectangle that I just drew represents is the width of our part and the length of one full rotation. So if I want to put text on here or a picture on here, this would be my center of the part. Or technically, this is 0 degrees. The middle would be 180, and this end would be back to 360. So that's how you can think of that full revolution. So what I'm going to do is I'm just going to lay down some text. We're going to do a couple little things here, some text and some kind of spirals around, some splines around there. So I'm just going to use a single line font. We'll keep it simple. I'm just going to say, excuse me. Let's do live, caps lock, live event part. All right, and I'm going to go in here and I'm going to take the angle and I'm going to rotate it 90 degrees. And then, excuse me, with this one, I do have some control. I could say I want to control the center of the geometry, the bottom left, bottom right. I'm going to go with just the bottom center, excuse me, and then I'm going to pick this and move it. It doesn't have to be perfect. I'm not too concerned with that. But right here, I want to make sure to set the height. I got to go a little bit smaller. Let's go 3/4 of an inch. That fits perfect. That looks great. So before I go and finalize this, I'm going to vectorize it so it's all broken apart. And then I'm going to hit OK and cancel out. Now, what I really should have done when I made that, and anytime you make text, you should always try to put it on a separate layer But I'll do that real quick. Just going to move all this, modify attributes, layer, and hit OK. So Mark just asked, what happens if you don't vectorize? I've just had issues with the letters being cut. Sometimes A's and some of the other letters that have a cross to them where they cross themselves. I've just had better luck when I vectorize them than when I leave them as unvectorized. Sometimes when I do an A, it'll do the TP part, but it forgets to come back and recut this. Or R's, like this line right here, it'll cut the outside, or it'll cut the bottom half of this, but it doesn't cut that final line. So it's just one of those things. If you plan to modify the text, so maybe you're doing a gang run of parts that has the same, it's different words every time, don't vectorize it. Because when you don't vectorize it, like right now, basically what vectorizing does is it breaks the entire group of text into separate lines and arcs. But if you leave it grouped together or unvectorized, you can always come back and redo it. You can remake the font. You can edit that font and change it. So if you're doing a bunch of parts where you're going to do a bunch of words, different words potentially, I would try and leave it unvectorized. But just be aware, some letters can get a bit goofy. All right, now, there's two other big things that we have to do. The first is get the geometry in the right place. The second is set up the wrapping group. So when I say we need to get the geometry in the right place, we're kind of picturing this a little off right now. Our geometry has to sit at the height of the radius of our part because our origin's top dead center. Or not top dead center, but it's in the center of the part, right down the middle of the part. So my stock is 3 inches. I know that I made it. It's easy. I just need to lift this whole thing up 1.5 inches. But I want to do it the wrong way first because I've done this to myself, when I was first learning out how to use 4-axis. And there's nothing more frustrating than having such a simple answer be the answer, but not knowing it. So I'm going to leave the geometry where it is. And let's go ahead and define that wrapping group. So I'm going to right click on Machine Setup 1. I'm going to go down to Additional Functions, just like where we go for the index. But this time I'm going to say Add a Wrapping Group. Now, when we add our wrapping group, we're going to define the diameter, which I'm just going to say use the stock diameter. My geometry is unwrapped already. That's the whole benefit of this, is I can lay my geometry out flat and let BobCAD be the thing that rewraps that geometry. So I'm not going to wrap it. Plus, it's very difficult to wrap geometry. It's tough to do in BobCAD even, or in BobCAD it's difficult. The origin is XYZ 0, so that's fine. So pretty much all I got to do is make sure the diameter's right and then hit OK. And then just like with the index, you're going to use the wrapping group. Instead of right-clicking on Machine Setup 1, you're going to right-click on your wrapping group. So I'm going to right-click here. I'm going to just do the Mill 3-axis wireframe. I love this toolpath. It's easy to use. I'll say Select Geometry. I'm going to pick the top of the geometry. I'm going to pick all that geometry right there. It sees that the top is 1.5. So we'll go ahead and hit OK. And we'll go next, and next, and next, and next, and next, until we get to the tooling page. And I'm just going to use just a little 1/8 inch ball mill here. All right. And then for the parameters. Now, we have cut to geometry and we have cut from geometry. Cut from geometry means the geometry is sitting at the top of the geometry and you want to cut from that geometry down into your part. Cut to geometry is going to cut to the depth of the geometry. And a lot of times when you're doing a cut to geometry, your depth right here might actually be 0. So I'm just going to hit compute. And so what's happening here is it's trying to machine from the OD to the center of the geometry. And the reason it's doing that is because according to our stock, we're not at the radius. All of our text is sitting flat right in the center. So to fix this thing, I'm just going to go to Utilities and Translate. Again, this is what you'll notice. If you tried to run a simulation on this, it's just going to destroy all the stock. But if I go in and I was to translate this, all this geometry up in Z, the radius of my stock, so 1.5, and then hit OK. Well, now I can go in, I'll repick my geometry, say reselect and OK. Now, I didn't set a depth before. This time I would now set a depth, and I want to cut from the geometry. So this is all sitting, if you picture this, it's sitting at the 3-inch diameter. So from the 3-inch diameter, how deep do I want those letters to be? I'm just going to go 50 thousandths, and I'll do it in one pass. Now, be aware the depths on this work a little bit differently than most other features. When we do depths on this, if I was to say, let's go 50 thousandths and thinking I want to do it in 2 passes, this is actually going to do 2 passes at 50 thousandths per pass for a total of 100 thousandths. So if I wanted to do 2 passes for 50, I would need to update this to 25 thousandths 2 passes. Basically, we need to make sure, we just need to multiply these 2 values together to get our final depth. And then when I'm done, I'll hit compute. And that's how you know you got it right, because the tool path will wrap around that cylinder, will wrap around that piece of stock that we had. So there it is. So now we'll go ahead and give it a save. So I'll say save as. Let's do wrapping example. Let me throw today's date on here. So 2-9-2022. And save. And then we can go ahead and start our simulation. So I'll just say start simulation. And then right here, we're just going to slow that down a bit. Say run, and you'll see, oh, let me turn on the machine. I don't think I put my, oh, I did adjust the stock. Okay, good. So you'll see that's how it's going to go, and cut. Beautiful. And there it is. So the biggest trick to remember when you're doing any sort of wrapping is you want your wireframe geometry to be at the height of the radius of the part. Now, if you were doing something like a pool cue, all right, so you have just a slight, ever so slight angle on your part, what you'll actually do is you'll set your geometry on the part and you'd add an angle to it. You'd actually angle the part. So you would take, instead of drawing this flat, you would have it match the angle of whatever it is you're trying to wrap around. Now, when you go to do your wrapping group for something like that, you'd go with the widest diameter of the stock, and that's what you'd set up inside your wrapping group. So there we have it. Now, how do you do more than one rotation? I get parts every once in a while where it's like a spline that we want to use, and it has to wrap around the cylinder 4 times. So what I'm going to do is I'm going to go to Utilities and Translate. And I'm going to translate this shape right here 4 times, or technically 3 times. So I'm going to say, pick my start. I want to go from here. The distance I want to move is that 9.4248 right there. For my geometry, I want to pick just the rectangle. So this is 1 rotation. That's 2 rotations. And I'm going to come with 3 copies total. So we have 4 total rotations. I could then hit OK. And there we have it. Now, there's a bit more to this if you're really doing this. But what I'm about to do now is just draw a line from this corner here to this corner all the way over here. And I'm just going to do a line, join to that point there, go all the way down to this point here. Just like that. Now I could also add more lines. I could shift this over. I could add, more lines the whole way and have different spirals that kind of pop up. But if I was to come in and I'm just going to copy the text toolpath we made, I'm going to paste it right below that. If I was to pick that line for my geometry, 1, it's already sitting at 1.5 inches in Z. So it's already at the right height. And because we did our calculations, we should end up with 4 even cuts. Now, I could also extend it past here. If that groove or that channel exits the part, then I'd want to go past this a little bit to make sure we exit past. But for now, I'm just going to go ahead and hit OK. and then go and compute that toolpath. Let me just blank out the other one, and there is that perfect spiral on there. Now, what I do need to look at is my probably clearance plane on here. So my top of feature should be at, let's say, 1.5, and then I can hit compute, and there we go. Now it knows to use that 1.5 radius. So I'll turn off that feature, the other text feature. I'll give it a little save. Again, I always like to save before the simulation, and then start the simulation. And then right here, let's see. Is there another way to make a proper thread around a cylinder? You'd have to know the pitch and all that stuff, and know, your settings for it. You could use if it's around a 4-axis, nothing really defined. Like the mill thread is going to be like a 3-axis, 2-axis, whatever you want to call it, style there. Not really. You'd have to figure out your pitch and all that stuff. But you may be able to use a program like G-Wizard or something would be able to at least tell you the distance between peaks so you can figure it out. But off the top of my head, making a proper thread, not some, maybe I could get 2 parts to fit together. But no, the thread mill doesn't translate to the 4-axis. It's all going to be like, single point thread mills from a top view perspective. So inside threads and outside threads. As far as I know, yeah, there's with those ones with the mill thread feature, you get to define the thread. So you can go in and say, I got a 1-inch 8 thread, and it's going to go in and thread it. But with this one, with any of these features, there's no way to tell it, hey, this is the size thread I want around there. You'd have to draw it out in the right way. And yeah, it'd be difficult. I've tried it with some guys that were trying to do it, and then I know one guy did successfully do it. It took him a while because he had to get a lot of depth set right, and all that stuff. But yeah, you could. He used some like 60-degree, I want to say it was like a 60-degree V tool that he slowly worked into the part along, just like how this is going to run, except he did multiple passes, and he had the whole thing. It was a much longer part. I mean, you could technically figure it out. You know how many threads per inch you need. So I guess for the, if you're doing a 3-inch wide part, you'd have to do a lot of math for it, is really what it breaks down to. So real tedious. So like right now, I didn't add any extensions onto here. So it might look a little bit, it might just plunge in. I could speed that up a bit. I'm just going to end up plunging in. Oh, that wasn't too bad. And so there we go. So as soon as we get back to the beginning, here is 1 full rotation, 2 full rotations, 3 full rotations, and 4 full rotations. Oh, we got a second depth. I forgot we're doing 2 of them. So there it is. And there's our little kind of spline groove or whatever. And again, basically, it's the cool thing about the way I do this. The reason I like this a lot is I now have this rectangle that represents the width and the length of my part, and so I could go in and anything I put inside that box can get wrapped around the cylinder. I can put a picture in there. Just make sure you just have to make sure that geometry is floating at the height of your part, or the radius of your part is probably the better way to say it. So there we go. Any questions? All right, give me 1 second.